So here is another question on projectile motion with angular projection. So it is given that a body is projected with a velocity of 40 meter per second from the ground. After 2 seconds, it just crosses a vertical pole of height 20.4 meters. Calculate the angle of projection and the horizontal range. Okay, so first let us try to understand the question. So let's say we have a vertical pole. Okay, this. It is of height how much? 20.4 meters. Okay, this is the height. Now we have a person standing who throws an object at a certain velocity of 40 meter per second, which is the initial projection velocity. So it undergoes this kind of a trajectory and it just crosses this vertical pole of 20.4 meters after a duration of t equals to 2 seconds. So it will then have this kind of a trajectory and finally it will reach the ground here. So we have to find this total horizontal distance covered and the angle of projection, this. Okay, so here you have to understand the question and then apply the respective formulas. Here it is given that after 2 seconds the body just crosses this vertical pole. So it means that after 2 seconds the body was which was projected from the ground, it was at the maximum height, okay, peak height after 2 seconds because it just crossed the vertical pole. So after this point the downward motion of the object it started. So this vertical pole height 20.4 meters, it is nothing but the maximum height of the projectile. Okay, it is the maximum height. Next, it reached the maximum height or it just crossed the pole after a duration of 2 seconds. So this t equals to 2 seconds, it is the time of maximum height. We discussed it in our theoretical discussion related to projectile motion with angular projection. You can watch that video. So time of maximum height represented as th, it has the formula of u sine theta by g. Okay, this is the formula. So here th is equal to 2 seconds, the time to maximum height. Initial projection velocity is 40. Theta is unknown, so sine theta. By nothing is mentioned related to acceleration due to gravity, so we'll put it as 9.8. So that implies sine theta is equal to 2 into 9.8 by 40. Okay, so it is coming around 0.489, so 0.49. so if we round it off, it will be 0.5 to simplify things. Okay, 0.5 or 1 by 2. That implies theta is equal to sine inverse of 1 by 2, which is equal to 30 degrees. So the projection angle theta, that is equal to 30 degree, that we have calculated. Next is the horizontal range. So the formula of horizontal range, if you are able to recall, horizontal range is equal to u square sine 2 theta by g. Okay, u square sine 2 theta by g. So we'll put the values 40 square sine 2 into 30 degree, which is equal to sine 60 degree by 9.8. So it is coming around 141.39, so 141.4 meters, rounding it off, 141.4 meters. This is the horizontal range. So horizontal range is equal to 141.4 meters. So here in this question, it was indirectly, mentioned that this vertical pole height is nothing but the maximum height. Why? Because it just crossed, this is very important, this phrase, just crosses a vertical pole. So that is the maximum height achieved by the projectile, and this time duration, 2 seconds, it is the time to maximum height. Okay, so these two things are very important. And then the formula, approach, we have, if you're able to remember the formula, it's great. Otherwise it will be very lengthy thing, because you have to then apply equation analysis to derive the formulas first and then go for the result. So it will be a bit lengthy. So my advice, always remember the formulas. Okay, so this is the thing. So here is another question on projectile motion with angular projection. So it is given that there are two buildings on either side of a street. A boy wants to throw a small gift packet to his friend across the street. The street is 40 meters wide, and the boy's window, it means the one who is throwing the packet, his window is 10 meters below his friend's window in the building across the other end of the street. What should be the projection velocity and projection angle? Okay, so this is the thing. So here let us first try to understand the situation here. There are two buildings . Then there is a street and there is another building. There is nothing, informed about the height of the buildings, nothing. There is a window on, let's say, this side of the building, where there is a boy, the first boy. Okay, he wants to throw a packet to his friend who is living somewhere here. Okay, the height difference, okay, between these two windows, it is 10 meters. Okay, the street is 40 meters wide, this. So now the boy, he throws the gift packet with a certain initial velocity and certain projection angle with respect to the horizontal, and for the gift packet to reach effectively to his friend, it should just be at the maximum height when it reaches his friend. It should be just at the maximum height. It should not be like this. It should not be going upwards, or it should not dip. It should just be in this manner, where it just reaches his friend on the other side of the street. So this height from this level, the height difference between the two windows, it should be the maximum height of the gift packet, which is the projectile here. So maximum height here should be the height difference between the two buildings, okay, for the packet to reach his friend, in a correct way. Now we know that whenever, let us take an example of a projectile motion with angular projection. Initial velocity, projection angle. So it undergoes this kind of a trajectory normally, okay. So here this is the maximum height and this is the range, the horizontal range, total horizontal range. Now at the maximum height, the horizontal distance covered by the projectile is half of the horizontal range, okay, at Sy is equal to h max. So when the vertical distance is equal to the maximum height, the horizontal distance is half of the horizontal range. This is the thing which we have discussed in projectile motion, the theoretical discussion related to projectile motion. So here, when the packet reaches the friend's window, the projectile is at the maximum height. That is the thing, that is the condition. So it means this horizontal distance, which is the gap between the two buildings, the width of the street, that is nothing but half of the horizontal range. Okay, this is equal to half of the horizontal range. It means that if this building would have, it would have not been present there, and there would have been no window, nothing like that, no obstruction, then this gift packet would have covered a total horizontal range equals to 80 meters. Okay, another 40 meters it should have covered. Okay, this another 40 meters, total of 80 meters horizontal range. So here the horizontal range of the projectile, if we do not consider this building to be present there, the horizontal range would have been 80 meters. So this is the condition. So R is equal to 80 meters here. Okay, but this is the thing, the packet reaches here, just the building present at a distance of 40 meters from the first building and with a height difference of 10 meters. So the maximum height is 10 meters and this horizontal distance covered by the projectile, by the gift packet when it reaches the friend's building to his window, that is equal to R by 240 meters. So this is, we will be using it for calculation purposes. R is equal to 80 meters and H max is 10 meter. So here, if you remember the relationship between H max, that is maximum height, and horizontal range, it is equal to 1 by 4 tan theta. If you put the respective formulas also, you will get the same result. Okay, you can check it out. So H max by R is equal to 1 by 4 tan theta. We have derived this relationship in one of the previous videos where we solved 2 or 3 questions related to this formula. So H max by R is equal to 1 by 4 tan theta. That implies here H max for this question is 10, horizontal range is equal to 80, that is equal to 1 by 4 tan theta. That implies tan theta is equal to 40 by 80, which is equal to 1 by 2. That implies theta is equal to tan inverse of 1 by 2, which is equal to, it's coming around 26.56 degrees, this much. This is the projection angle. Okay, this is the projection angle, the first part of the question. The projection angle is equal to 26.56 degree. Next is the projection velocity, the initial projection velocity. So here we can use any formula here, whether it is for maximum height or for horizontal range. So we'll be using the maximum height formula. So we know we have calculated here that H max, it should be equal to how much? 10 meters. The formula of H max is equal to u square sine square theta by 2g. U we have to calculate. That implies u square is equal to 2g H max by sine square theta. Okay. So here we'll put the values. That implies u square is equal to 2 into 9.8 into 10 by sine 26.56 degrees whole square. So it is coming around, u square is coming around 980.345. okay, 980.345. that implies u is equal to root over of 980.345, which is equal to 31, so rounding it off, 31.3 meters per second. This is the projection velocity. So the projection angle is equal to 26.56 degrees and the projection velocity is equal to 31.3 meters per second. Okay, so this is the okay. So here we have solved this question. So here you have to use your understanding of projectile motion to figure out that for the packet to reach in a correct way, in a comfortable way to the friend's window, it should just cross the window when the packet is at the maximum height of its projectile motion, which is the height difference between the two windows. And at the maximum height, the horizontal distance covered is half of the horizontal range distance. So these two parameters, if you are able to figure out and you remember the formula, then it's just very easy to get the calculations done. And another thing you have to take care of, always pay attention while you make the calculations, because it's very easy to make silly mistakes here and there, because there are a lot of intermediate calculations involved, lot of division, multiplication, squaring. So it's very normal to make silly mistakes here and there. Okay, so just be careful about that. So here we have done it. So friends, I hope you liked this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.